In this video, we're going to learn all about Blazor component render modes so that you can control how your components render and deliver a great user experience. Now, by default, Blazor components are statically rendered from the server. We call this static server-side rendering, or static SSR. When a request is routed to a static component, the component renders plain HTML to the response. And then its job is done. The component instance goes away, and there's no state maintained on the server. Static components are great when you just want to render some HTML content, and you don't need to handle any UI events. Now, most of the components in our default Blazor web app are statically rendered. They're static server-side rendered components. For example, this home page, the weather forecast page, and all the layout, those are all being rendered statically from the server. Now, we can see this by just looking at the page source. If we go to View Page Source on the home page, you can see here's the HTML content for that page, hello world, welcome to your new app. All this HTML up above, that's all the layout. It's just HTML being rendered from our component into the response stream and then being shown in a browser. That's static server-side rendering. Now, Blazor can enhance static components in various ways to make the user interactions feel smoother and more responsive. For example, Blazor can enhance page navigations by intercepting the page navigation and doing a fetch request instead. Blazor will then compare the statically rendered content from the server with what was already rendered into the DOM and apply just the needed changes. Enhanced navigation helps pages to load faster and smoother without needing to do a full page refresh. Blazor will enhance page navigations by default, and you can also optionally enhance form requests too. We can see enhanced navigations happening in our Blazor web app. And to do that, we're going to bring up the browser dev tools. I'm just going to hit F12 on my machine. Okay, and then let's refresh the home page to see what's being downloaded for the home page. All right, so now here we can see, let me zoom in a little bit. We can see that this is the initial request for the home page, and you can see it's of type document. So it's a normal browser page load where it's downloading the entire HTML, and then below you can see that it loads up all of the style sheets and JavaScript files that are used to render that home page. All right, but if we now browse to a different page, like the weather forecast page, let's see what's happening there. Okay, here's the request for the weather forecast page, and you can see that now, instead of a document type request, it's a fetch request. Blazor intercepted that navigation, did a fetch request instead, got the statically rendered HTML content from the server, and then patched it into the DOM. And notice that below that, we don't have to re-download any style sheets or JavaScript files. They've already been downloaded previously. They've already been applied to the DOM, so we don't have to do any of that extra work. So the page loads fast and smooth and feels more responsive. It feels kind of like a client-side JavaScript-based app, even though it's still doing static server-side based rendering. So that's enhanced navigation and form handling. Now, Blazor also supports streaming rendering. Streaming rendering is great when you have a page that needs to do some long-running asynchronous tasks in order to fully render. With streaming rendering, you can render the page immediately, get pixels on the screen really, really fast by just putting some placeholder content while those long-running async tasks are executing. Like maybe you're pulling some data from a database or making a long-running API call. When the async tasks complete, the component will then render again to the same response stream. So imagine like you do a request to pull down a page and it needs to go to the database to get some data first. So it renders initially some HTML, and then you get that like a placeholder of some sort, like loading ... Once that database query has completed, then Blazor will render your component again and stream down an update to the browser on the same connection. It's not a new connection, it's not a WebSocket, just the same connection that was used for the original request. And Blazor will intelligently patch the new HTML into the browser so that the user sees the new UI. So you get pixels on the screen really, really fast, and then streamed updates are applied automatically. Now we can see streaming rendering in action on the weather page. If we refresh the weather page, and I'll try and catch it while it's happening, so I'm going to refresh and click. Okay, so I've captured it. You see this loading ... We've got the layout. We have this little placeholder while we are, going off to some API someplace to fetch the actual weather forecast data, which might take some time. And then if we let that render, then a streamed update comes in with the actual weather forecast table, and that's what's rendered to the user automatically. If we look at the code to see how that's done, here in the weather.razor component, up at the top, we can see that streaming rendering is being turned on by applying this stream rendering attribute. And then below, we have this if check that's checking, well, do we have the weather forecast yet? If not, then we're going to render this loading ... placeholder. Down below, if we do have the weather forecast data, then that's when we're actually going to render the table. Loop over all the weather forecasts and render them to the screen. Even further down, we can see the onInitialize async method that's setting up the weather component. And you can see that we're not actually doing an API call here, but we're simulating one by having this task.delay that we're awaiting. So onInitialize async runs, and it's awaiting that async task, so execution yields, and that allows the component to immediately render some initial HTML down to the browser. And then once that's done, we then generate all the weather forecast data. Then the component renders again with the weather forecast data, and that update is streamed down to the client. So streaming rendering, pixels on the screen super fast, and automatically applying streamed updates. Great for pages that have these long-running asynchronous tasks. Now, of course, we also want to be able to build Blazor components that are fully interactive and can handle arbitrary UI events from the browser. For that, we need to enable client interactivity using an interactive render mode. You can enable interactivity for individual components or pages to sprinkle on a little interactivity wherever it's needed, or you can enable interactivity globally for the entire app. Now, Blazor provides two different ways to make components interactive. You can do it from the server or from the client via WebAssembly. An interactive server component will still run from the server, but it has a real-time connection with the browser over a WebSocket connection. As UI events happen in the browser, Blazor sends them to the server for your components to handle. As components render updates, Blazor takes care of patching the changes then efficiently into the DOM. Interactive server components are super convenient because they are already running from the server and have access to all of the server resources. They do require an active connection with the browser in order to function, which can impact latency as well as your server costs. Now, alternatively, you can run components directly from the client via WebAssembly. Blazor can run your .NET code directly in the browser by downloading a small .NET runtime with your app that's implemented in WebAssembly. Interactive WebAssembly components render and handle UI events directly from the browser, and then apply the updates directly to the DOM, offloading the work from the servers to the client. Now, downloading the .NET runtime may increase the load time of your application, but once it's been downloaded, it's cached then for future use. Now, there's actually also a third option that combines the strengths of both interactive server and interactive WebAssembly rendering, the interactive server and WebAssembly render modes. The interactive auto render mode will initially render a component from the server while the .NET WebAssembly runtime is being downloaded in the background. Then, once the WebAssembly, the .NET runtime has been downloaded and cached, the component will automatically switch to WebAssembly-based rendering for future visits. So your app loads fast initially from the server and then switches to WebAssembly automatically, offloading work from your servers to the client. That's the interactive auto render mode. Okay, let's go take a look at these interactive render modes in action. Now, the one component in our default Blazor web app that's interactive is the counter component. It has a button and it handles the on-click event for that button. That's how we're able to make that count increment. And if we go look at the code for how that counter is implemented, we can see at the top that it is using an interactive render mode, which is applied using this render mode razor directive. And you can see that it's using interactive server rendering, which is what's enabled for the default Blazor web applications. Okay? So back at the app, if we, let's bring up the browser DevTools so we can see what's happening. Okay, let's just browse to the home page and then back to the counter. And then I'm going to filter just on WebSocket connections by using this WS filter, WS for WebSockets. And there is the WebSocket connection for our counter component. This guy right here. This is what's handling all of the, pushing all the UI events to the server and letting our components run from the server, then handling all of the UI updates that then come back on that connection. And you can see that the WebSocket connection is currently active. It's in this pending state. It hasn't completed yet. There's not a completed request time. All right? But if we, so it's working. And so if we browse away again, let's go back to the home page. Now watch for it right here. See the pending changes to a number? Did you see that? So it's no longer, the WebSocket connection is no longer active. It's been closed, and those server resources have now been freed up because we browsed away from the counter page. The home page is just being statically rendered from the server, so it doesn't need those server resources being allocated. They can be freed up, and your app scales better. But if we browse back again to the counter page, now we've got another WebSocket connection. It's back in that pending state, and so we've got interactivity enabled again for the counter. Cool. So that's interactive server rendering. You enable the interactive render mode using the render mode directive attribute, razor directive attribute. Okay, now to enable interactive WebAssembly rendering, we actually need to set up a separate project in our app. And that project's going to be the client project that holds all the code that we want to actually download to the browser. The default Blazor web app template isn't set up for that, but we can create a new project and pass some additional options that will enable interactive WebAssembly rendering. So let's go ahead and do that. Okay, go back to our code. And let's just go ahead and stop the current app from running. And then we will go up a couple of directories here. And let's create a new Blazor app. So .NET new Blazor. And the way you specify which interactive render modes that you want to enable is using this interactivity option. Okay, and there are various options that you can pass. You can say, I don't want any interactivity. I just want static server-side rendering, which is fine. You can say, I want, let me go back. .NET new Blazor. And actually, there's a short form for interactivity, which is just -int, so we'll use that. So the none. We could do server, we can do WebAssembly, which says I just want WebAssembly interactive rendering, I don't want server. Or we could say, give it all. We want all the render modes by saying auto. Auto will turn on both server and WebAssembly. Now this just configures the app to enable the render modes. It doesn't mean all of your components will use those render modes. You can still choose which components you want to be interactive and which ones you don't. Now for this project, I want it all, so let's go ahead and pass auto. Okay, and then for the project, let's do Blazor app 2 for its name, and let's go ahead and run that. Great, so now let's run code Blazor app 2, and we'll just open that up in the same window. All right, cool. So here is now our new Blazor web app, which should be set up for all the interactive render modes. If we look in the Solution Explorer, we can see that instead of just the single project that we had before, we now have two projects. So the top project is our server project. That's where all of our server code lives. Very similar to the Blazor web app projects that we've been looking at so far. But then below, we now have a client project. And this is the project that's going to build all the code that's going to be downloaded to the browser and run client-side on the user's machine. If we look at what's in each of these projects, in Program CS, let's just scroll down a little bit, we can see that it's actually turning on both interactive server and interactive WebAssembly render modes in Program CS. But otherwise, most of the code in the server project is exactly the same. We see our root app.razor component. We've got all our pages. We have the home page, the weather page. Wait, where did the counter go? Where's our counter page? Well, that has now moved down to the client project. So counter.razor is now set up not with interactive server rendering, but with interactive auto rendering, which means it will eventually run on WebAssembly from the client. That means it has to be built out of the client project. That's why it's been moved down there. Any code that you want to be able to run from the client's got to live in the client project. Okay? So if we go ahead and run this, and by the way, we could have done interactive WebAssembly render mode for this as well. That would have worked fine, but let's go ahead and do the fanciest scenario, interactive auto. Okay, so let's go ahead and run this project. Bring up the terminal. And then we want to, which project do we run? You actually want to run the server project. The server project is what hosts the client, so it's the thing that you actually need to get running. So we'll go into the server project and .NET watch that. All right, cool, there it goes. So here's our new Blazor web app that should have interactive auto rendering enabled. So let's bring up the browser dev tool so we can see what's happening. Now on the home page, we just have static server-side rendering. So let's browse to the counter. Okay, and I got all sorts of stuff being downloaded. Let's filter on WebSockets again. And there we can see the interactive server WebSocket connection being set up. It's currently in the pending state, so we know it's active. And if we click the button, the counter is working. So this is currently using interactive server rendering. But you may have seen that if we filter on WebAssembly, that all this stuff was downloaded in the background. There's the .NET WebAssembly runtime right there, that .wasm file. That's what's going to allow us to run .NET code from the browser. And then we have all these other, libraries that are being downloaded so that we can actually run our application code. And this looks pretty big. You're like, whoa, what is all this stuff we're downloading? Don't worry. When you publish this application, we'll run a trimmer over your Blazor web app to trim out all of the libraries and code that the app doesn't actually need in order to run and make it much, much smaller. During development, we don't bother running the trimmer. We're trying to make the developer experience fast and iterative, so it looks a little bigger during development. But when you publish it, the app will be shrunk way, way down. Okay, but we're not using WebAssembly yet. If we go to the home page, we can see that the WebSocket connection should be closed, and there it is. It's no longer pending. And then if we browse back to counter now, okay, we don't see a new WebSocket connection being created, but if we click the counter, the count still goes up. How is that working? Well, it's now running on WebAssembly. It's automatically switched from interactive server rendering to interactive WebAssembly rendering. All right, so that's how you can enable the client-based interactive render modes, both WebAssembly and auto. There's convenient template options for doing that. Now, so far, we've only enabled interactivity for one component, like just one page, the counter component. What if you just want interactivity throughout the entire app? You have lots of interactive features, and you're just going to really want interactivity everywhere. Well, you can do that too. You can do that by creating one more project. Let's go back to Visual Studio Code. We'll shut down this application, pop up a couple directories, and now when we create this third project, .NET New Blazor, we'll still use auto for the interactive render mode that we want, but we'll also pass in one more option, which is this all interactive option. What that's basically saying is, please just make all the components in the app interactive for me. Don't make me specify which ones I want to be interactive. All right, and there's a shorthand for that, which is just -AI, and we'll call this app Blazor app 3. I think we'll be good. All right, and so now let's